Hey everyone, it's the ME Tutor. I'm coming here to teach you some simple solutions on first order differential equations. Just kind of go over what a first order differential equation is. Basically, it's like an equation when you derive it, it equals itself. So what we're trying to do with this equation is we're trying to figure out what the general solution is. That's what we're going to do. So to do that, first thing we got to do is we have to get it into this form. It's going to be y prime plus p of t equals, y equals g of t, which is a general form. We have to get into this solution. So if there was a y, let's say this y was on this side, we would have to add it over, kind of like what it is. So basically you just want to get in that form. And that p of t, in our case, is going to be this 3 here. So to do that, we kind of go over here because we're going to find our integrating factor. So kind of like a shortcut without like deriving what it's from is this thing is going to allow us to integrate easier. So we're just going to say mu of t is equal to 3 integral to the exponential function. So when you take the integral of this is in dt, so this would become 3t, and then you take the e power to it. So we're going to multiply this factor on everything. So we're going to multiply that over here. So this would be y prime e to the 3t plus 3y e to the 3t. And then it's going to be t e to the 3t plus e to the t, basically. Because the 3 and the 2 will kind of multiply each other and they'll add out, and then you'll just get e to the t. So now we're left with this, and what this allows us to do is basically what's happening here on the left side of the equation. We have y prime to the 3t power plus 3y to the e to the 3t. Basically what this is, what I just underlined, is we're going to kind of put the derivative on the outside. So it's going to be d dt and integrate, and then it's just going to be y e to the 3t. So that's basically the derivative. When you take the derivative of this, you get this function. And to prove it, I'll do it over here real quick. So we have y e to the 3t. So we have to do product rule. So this would be the derivative of the first, which is y. So we just turn to y prime e to the 3t, which is what we have there. And then you take the derivative of the second function, and the 3 would come out, 3 e to the 3t. So I just proved that that is that derivative. You don't have to, because that's the whole point of what the integrating factor was. So that happens, so that crosses out, and then we're just left with y e to the 3t, and that's going to integrate this side. So I can do this part right here. So we integrate here, integrate here. This one's kind of easy, right? So it's just the integral of e to the t, which is going to be e to the t plus c, but this one's hard. So since it's t times e to the 3t, we'll have to do integration by parts. So I'll do that for you. If anyone doesn't remember, I'm going to write the equation up here. It's going to be the integral of u dv is equal to u v minus the integral of v du. So what we have to do is we have to pick a u and a v. I'm going to skip through this a little bit because I'm going to assume that you understand different integration by parts. If not, leave a comment down below and I'll be more than happy to make a video over that. But so basically, we're going to pick our u and the v. So u is going to equal to t, and our dv is equal to e to the 3t. And take the derivative of that, u equals 1 dt, and the integral of this will be v equals 1/3 e to the 3t. All right, so we have this, and so we're going to plug it back into the equation up there. So it's going to be t over 3 e to the 3t minus the integral of 1/3 e to the 3t plus, d, which is just 1. So we're going to integrate this side real quick, and that's going to be 1/9 e to the 3t. Alright, so I'm going to plug these back into the equation over here to get the right side now. So we're left with t over 3 e to the 3t minus 1 9 e to the 3t. Okay, so now we're kind of, we have both sides. Now we have to solve for y. So basically all we're going to do is we're going to multiply the inverse kind of function of e to the 3t, which is going to be e to the negative 3t on everything. We're multiplying, because basically what that'll do is that will cancel that out. So we're going to do that on the right side as well. So y is equal to t over 3 plus, or sorry, minus 1/9. Oh, that's a plus sign up there. So we're left with e to the negative 2t, because it's going to be negative 3t's plus t will give you a negative 2t, and then this is the tricky part. So we take e to the negative 3t on side of c. Oh, I guess it's not really tricky. Just multiply it on there. So this is constant, and that is your answer. Thanks for watching my video, guys. Like and subscribe if you like this. Feel free, if you have any feedback, leave a comment down below, and have a nice rest of your day. And look forward to our second order differential equations. I'll be getting that out here soon.